Thank you. Good afternoon, everyone. Today I want to talk about why I use D so much. And after thinking about it, I found out that the reason I like it so much is because it's a jack of all trades. It says it right on the home page. The best paradigm is not to impose something at the expense of others. And D offers all these kinds of paradigms, such as object-oriented and contract programming, all harmoniously integrated. And, well, the flip side of that is that a jack of all trades is a master of none, as the saying goes. You know, you have all these paradigms, but you don't go to the fullest extent for each of them. But the full saying is actually, it adds, but oftentimes better than a master of one. And that's what I'm going to talk about by first kind of going over some of the advantages and disadvantages of D being like this. And I'll also show some of my projects where I use D in some rather esoteric environments and kind of show like you can truly use it in any scenario you imagine. So as a first-time speaker, I thought it would be good to kind of introduce my own programming because it also gives some context to where I'm coming from with my points. I started programming in 2008 in GameMaker. As the name implies, that is a game engine. And I was writing games, also some other things, but primarily games. GameMaker came with its own GML language. Here's a code snippet of it. What I really liked was that all code does something. There's very little like boilerplate with class. Like it just reads almost like English text. If keyboard is pressed and you're on the ground, then you can jump and you play a sound. And one thing I also really liked about it is how in the editor you could just compile it to one single executable file, send that file to your friend, he would double-click, and he was running your game. That's pretty good user experience, in my opinion. From 2015 onwards, like the next 4 years, I suddenly started using a lot of other languages. What happened here? Well, I started my Bachelor of Computer Science at Delft University of Technology. So they have all kinds of courses there in all kinds of domains, and many of them have like a specialized language. Though the main language we used was Java. We used it for basically the basic algorithms and software engineering stuff. In Java, not all code does something. There's a lot of boilerplate and factories and stubs. Here's an example that kind of illustrates the problem. But actually, it wasn't even the language itself that was so, like it wasn't that much worse than GML. But it doesn't compile to an executable, but to a jar, and it requires a setup, not just for you, but also for your friends who wants to play it. And at the time, there was, like, this was what Java setup looked like. It tried to install some crappy toolbar in your web browser, and that is just unacceptable user experience to me. So I always thought, I should, for my own projects, use C++. It's going to be my favorite language once I learn it. Of course, you find some things that you take for granted in Java. Like in C++, I got segfaults instead of exception traces when I was dereferencing a null pointer or doing endless recursion. And also, I still had to ship glf3.dll, which is a windowing library, because unlike GameMaker, C++ does not come out of the box with functions to check for keyboard presses and things you need in games. And I wanted to not have, like, to also send this DLL alongside the executable, but it turned out to be really hard to embed it in C++. One fateful day, I found D on a benchmark site. So I was kind of curious about the performance gap between C++ and Java. And I can't find back the original sites exactly, but I remember seeing a table in there that looked like this. And I was like, they made a sequel to C++? And it's not even like that much slower. It's the same performance ballpark. Yeah, after checking out some of the articles, I was kind of convinced, like, yeah, this is a language with good rationale. They had all these articles saying, like, oh, this is the clumsy way you do it in C and C++. And here's the obvious way that you do it in D. Yeah, I was sold. Of course, there's also the meta-programming thing, which I wasn't familiar with, but it reduces boilerplate, which harkens back to my point that I like code that does something. And it compiles to .exe, being a native language. And on top of that, on the D idioms block, I found like my exact use case of embedding a dynamic library in an executable. And it's as simple as one line of code. You just import, give a file name, and it's as simple as that. And that's kind of like the character I give to D. A lot of things that, why doesn't it just work? Well, in D, it does just work. So yeah, afterwards, I didn't, for my personal projects, I kept using D. Here I listed some of them, and I'll cover some of them in my talk. And why didn't I not use specialized languages? You know, I got an introduction to all these languages from my university courses, but still I kept writing code in D in all domains that I ever touched. And it's not so obvious that one language to suit them all is the right choice, because it does result in a lot of complexity in the language, which I'm going to discuss now. First of all, there's some complexity in the specification. So this is the section of the grammar that describes conditional compilation. It includes just version and static if. And this is the entire syntax of Lua. It covers everything. Like, it fits on one page. And D has like pages of grammar. And I was so impressed when I saw this, like, that's it? You know, you don't have to make a complex language. And this manifests as complexity for the user sometimes, because when I need to aggregate two integers, in many languages there's just one sensible option. In C you have a struct, in Java you have a class, in Lua everything is a table. In D, well, you have structs, classes, a phobos tuple, not to be confused with a compiler tuple, and a static array. And it's great that it has these options if you need them, but when prototyping I often find myself kind of slowed down by having to consider these options. In these other languages, I just surrender to the fact, like, well, I have to use a class. But in D, I just always have this idea that I should at least consider all the options. Finally, the complexity also shows in the design of the language. So this is a simple example of string interpolation, where instead of, like in the first right line, I have to alternate strings and variables to kind of concatenate them into one. Wouldn't it be nice if you could just put your variable directly into your string literal? This is a feature that exists in other languages. Why don't we just add it to D? There's popularity for it. It's like the third item here in the State of D survey from 2018. Well, we tried, but you know, the first dip got rejected, second one got withdrawn, and the third one is still a work in progress. Why can't we just get it in already? Well, D being such a big language comes with its own design challenges. Like, we have not only just runtime parameters, but template parameters to consider. We have add_no_gc, which are functions that don't use the garbage collector, which is a shame because the garbage collector is what makes interpolated strings so easy to work with in scripting languages. We also have the unique challenge of generating code and mixing it in with a string mix-in, which also means that things like using braces to delimit variables is not a good idea, because braces also appear in your D code that you want to just mix in. So some people want it to work with printf for some reason, and despite all these challenges, we still want it to be simple and easy to use. We don't want to introduce a bunch of corner cases in the language. And you know, anyone can come up with a complex solution, but it takes a genius to come up with a simple solution. So now the question is it maybe better to not have one language that fits everything, but instead mix languages? For example, write high-level parts in Python and low-level in C, or scripting parts in Lua in an application written in C#. Well, I have had some experiences with that, and this is why I'm going to cover them, and we'll kind of see how that works out for me. So for one of the university courses, we were programming a quadcopter, and it had a little embedded board, had some embedded code written in C, because it's low level. But our team, we were doing this in a project, in a group of 5. We wanted some extra credit, and we decided to implement a GUI. And for that, we used Python, because it's more high level and has all these libraries for mathematical plotting and such. And the GUI would kind of just show the sensor values and help kind of see why it keeps crashing into the ground. But how do we send the data from C over to the Python GUI? Well, we wrote this awful big printf statement that just generates a big string of JSON and then send it over to Python via a socket. Needless to say, this is kind of hard to maintain. And every time you change or you add a variable, you have to also, don't forget to also update this monstrosity. So that was one example of why it didn't really work to mix those two languages, why it wasn't very ergonomic. Another one is where I got to do some Lua scripting. So who knows this game? Super Mario 64. See some hands? Yeah, I love this game. It was a pioneer of 3D platformers. It was back when these games were still on cartridges, while other consoles moved on to CDs. And while I was coding in GameMaker and struggling with my 2D collision checking code, I always wondered, how do the big guys do it? How did they make all this 3D collision checking? Well, and that's how I kind of got involved with reverse engineering the game. And there's actually a bit of a community around it, because people are to this day still doing all kinds of challenge runs, like speed runs and trying to beat the game without pressing the jump button, which you might have heard about. It gets very technical. So, but for my reverse engineering efforts, I was using the BizHawk emulator, because how do you debug this? Well, on the Nintendo 64 console, it's really hard. It wasn't a game that was brought on PC, so I run an emulator on my PC that mimics the Nintendo 64. And with the Lua scripts, you can kind of poke the RAM and print some variables. And it's supposed to be easy, right? Lua scripting, it's a scripting language. You get started very quickly. But what I found there was that small scripts quickly turn into bigger projects. And the complexity increased, and it's no longer really a script. And it happens always very suddenly. I never noticed that my code has become so large until I found some runtime nil errors, and I have to kind of backtrack and find and untangle the spaghetti I just created. So one common problem I got with nils was that some library function said, oh, I don't want to convert a nil to string, but where did the nil originate from? Well, it originated all the way back from my tables, which were missing some entries. So I actually wrote this function, which is a big function, to kind of go over my tables and check the types and print errors if some field is missing or has the wrong type. But it was it's kind of annoying that my code that actually does something has also this big block of code that just for checking. Can't I just reduce it to some small annotations and then put the checking? Static typing. I just wanted static typing in my language. And I'm glad that there's now some typing information in Lua. At the time, in this emulator, there's no support for that. So that's why I wasn't very happy with Lua scripting in this emulator, unfortunately. The domain was it got just a bit too complex for a script. Meanwhile, the reason why dynamic typing is sometimes praised is that you don't have to type all these types. But in D, you also don't have to write types, right? It is a static type system, but still, I don't write int here. I just write a generic max function that returns the maximum of 2 numbers. And I just write a t in there. I don't say it's int, but you can instantiate it with int or float or any number type that implements the comparison operator. And then when you call it, it automatically instantiates with 2 integers. And then the variable x is also typed int. It's all inferred, never did I write in? So in my conclusion, I don't like scripting languages that much. I prefer static typing because it never stays with scripts for me. And I want to highlight one piece of design that I really appreciate and I think is a bit underappreciated in D, and that's the fact that there's just one slice and dynamic array type. And I've heard some people say that it kind of conflates two different concepts, slices and dynamic arrays, but for me, I really like how I can write a low-level function that just uses some C function, does some low-level string generation, then easily pass a slice to that to some high-level function and append to it. But this was like stack allocated data, and I can just append to it. It will not corrupt memory. It will GC allocate, copy it there, manage it, and then you can use it. Nowhere did I have to convert from like the crappy built-in array to the array list or std vector that's actually good. There's just one obvious, simple array type that works with everything. As some user on the forums put it, Mikri, the D2D foreign function interface, as it were, is really good. So now I want to talk about some of the esoteric targets where I ran decode. So going back to Mario 64, I wanted to implement a collision viewer where it kind of shows like how the game internally sees the world and how you collide with it. But yeah, the Lua API was too limited for me. I could maybe draw one triangle, but more than that, it would slow down significantly. So the other option I had was to just hack the game's source code, right? It's very easy. Just write some MIPS assembly, because the Nintendo 64 uses the MIPS architecture, and inject that into the main memory instead. But of course, this led to a lot of bugs because handwriting MIPS assembly isn't very practical. All these instructions, all they do is just generate a pointer into an array. And yeah, you can tell it's a RISC architecture, because in x86 it would just be one instruction probably. But yeah, so an alternative would be to maybe write my own language. I could make a bit of a macro assembler, because the problem with just existing assemblers and programming languages is they usually compile to some binary file, and I want it in a running emulator process. So, and I also just like doing projects even if they aren't the most practical thing. Sometimes it's just fun to code and try some new approach. But I haven't created my own programming language yet. I refrained from it. I found out that the LDC compiler actually has the flags to generate MIPS code. And it also has the output-s flag to generate like the assembly code instead of just object code, which I could maybe feed into my own assembler. But I found a bit of a problem with the labels, because sometimes an instruction says like jump to this label, but the label is defined further down the line, and you don't know the address of that label yet until you get there. So after reading up a bit about solutions, I found out that this is a job that the linker usually does. The linker has this relocation table, which is basically just a list of to-do lists where it says, I wrote 0 for now, but after linking, go back and put in the actual address over there. And it turns out that linkers are actually pretty simple. There's this great quote from Walter. A linker is a very stupid, pedestrian, straightforward program. The tedium in writing a linker is usually all about decoding and generating the usually ridiculously overcomplicated file formats. But if you do that, you don't even need the assembler anymore. You can just write a simple linker. And I can attest to the fact that they are ridiculously overcomplicated. For one, I was using the ELF binary format, but it's also the same with other formats. For one, there's a lot of sections that I just don't need. Like I'm interested in the code, not some kind of meta data. But also, MIPS defines like 100 of these relocation types. I implemented these 4. This was all I really needed. I don't know why there are so many. Like, I know there are some things I didn't use, like thread local storage, but in my opinion, these should just be good enough for all the code, for most code. So the result, I'm actually going to try a little live demo. So let me boot up the emulator. So I'm trying to insert this D code into the emulator. I'm gonna run the game. All right, so I have the game running here. And I would like some input from the audience, because I could have just written this secretly in assembly. Let's add some string. Does anyone know a funny word, funny phrase, something short? Just scream it.
D-rocks.
D-rocks. All right. Let's try this. Put it a bit lower. Then I'm in my demo 0. Sorry, Roberto, I count from 0. I'm a programmer. OK, so I ran this command over here, just LDC, and I passed this file. Now it's generated this assembly file, as well as the object file that I'm actually going to use, which I can view here. Let's see. Then I added a bit of a map file, because the game has some functions, and I need to tell the linker, like, here is the address of these functions. And it seemed it worked, so let's see if it actually does. Hey, it says D-rocks over there. And above. Thank you. So yeah, and the thing that you already saw probably was a simple A-press counter, which you're trying to minimize in certain challenges. Yeah, I can also maybe even show in the hex editor.
Yeah, I see it. Line 60. Yeah.
Let's see if Windows magnifier works. Unfortunate, I cannot enlarge it with the Windows magnifier. But yeah, it's in this is the code it inserted directly into the emulator without, writing to disk. And this was just a toy example. What I actually used this for was like for some actual application. I have this replay. So there's this things that the Mario 64 community does called task competitions, where contestants are given like a week or 2 to create their own speedrun in an emulator, and they just submit all their runs, collecting some coins and finishing as fast as possible. But all these separate speedruns, I thought it would be really cool if you could actually see like them all in at the same time. But the game is not multiplayer, so I wrote D code to actually enable this. And yeah, I wouldn't have want to write this in MIPS assembly ever. So let's see. Let's close the emulator, or else my battery is going to drain before the talk is done. Let's go back. Yeah. So the result was that I wrote these ghost compilation. So yeah, of course, not the full D feature set is supported. It's a very restricted feature set, basically like better C, but even less than that, because sometimes LDC at the time did not implement everything for MIPS, like passing structs by value. So you sometimes get a cryptic error like that. But still, it's a lot better than assembly. And of course, there are still benefits of using D over C, even in a restricted feature set, like the familiar syntax, reusing your already written D code. And the import statement from before also came in handy here to just include all the replay data So for my next example, where I ran D on a, well, not that esoteric target, but not very well supported target at the moment in the browser. So usually when you write code for the browser, like your options were for a long time limited to JavaScript, and there were some like options with plugins for Java applets and Flash Player, which are now phased out. But in recent years, browser client-side coding became more accessible with WebAssembly, and in summer of 2018, LDC added this target. And so I wanted to try it out. I could finally write code for the browser now that actually I could use D instead of JavaScript. But it's still very limited. Similar to the Nintendo 64, there's no runtime provided. It's basically just an instruction set. But at the time, I wrote a simple, a decent ultimate tic-tac-toe game, which is like an extension of tic-tac-toe that's a bit more interesting. And this was using better C. But an example that's a bit more impressive was my exact math calculator. So sometimes I want to simplify a formula with variables, like square root of x plus x times x. And you can go to Wolfram Alpha, type it in, and then it takes a while for the server to respond, but eventually it gives you some result. But this is not programmable. You can use Mathematica, but that's not open source. And I was looking for some open source alternatives, but I tried some keywords like, variable math library, exact math library. I found a lot of libraries that work with numbers, but none that could really handle just an x. So I started writing my own, thought it was another fun project. And yeah, I did find out that SymPy exists, which is basically what I was exactly looking for. Turns out the magic words were computer algebra system or symbolic math. But I still kept on going because, this is Python. And second of all, I had some cool ideas you could do with D. For example, using generic number types, because D has operator overloading, you can define your own number types. And I thought it would be cool if I could make a symbolic math number where you could, instead of an integer, you could also have a formula like 3 plus x, and make it a drop-in replacement for float. So here's another generic function. This inverts a 2x2 matrix with a generic number type. And you can instantiate this with float and double. But it would be cool if I didn't have to write a separate matrix inversion logic for my symbolic math number. But the challenge is a float is a value type. So when you assign one float to the other, you get a copy, and you can modify it, and the original remains untouched. But when you have a tree data structure, you have indirections to the child nodes. And if you have mutable aliasing, then you may inadvertently also modify the original variable. But D actually has a solution for this, and this was inspired by big integer in the standard library and the invariant strings, the Digital Mars article, which talks about why a string is an immutable char array. By using immutable on the element type, you are guaranteed there's no mutable aliasing. So you can just implicitly convert a const math number to a mutable one. And that helps it really feel like you're just using a simple 32-bit float, but it's actually secretly a big complex tree object. So I wanted to use WebAssembly for this. That's what I started with, using WebAssembly. And normally I use all the attributes in D, like pure, I don't like global variables, safe, I don't like memory corruption. No GC, no throw. It's not per se bad to have allocations and exceptions, but when you run on these esoteric targets, you don't have the runtime available, so it makes your code more reusable if you don't use it. But for this one, I did use a GC because this was one instance where I really didn't want to manually manage the memory in a tree data structure. I was trying to get the math correct. I didn't want to get the memory management also correct at the same time. So my previous WebAssembly example used the better C subset, but this one used the GC. So what happens if I remove the better C flag? Well, the runtime is unfortunately not ready for that yet. Currently, there are a lot of errors because it doesn't define certain C constructs for the WebAssembly target. And the solution to that is you can actually use your own object.d. So object.d is this module that gets imported implicitly into every D module, and it also imports all the things that cause the errors. But if you just pass your own object.d to the command line, then it will use that instead, and you can just implement the parts of the runtime that you actually need. So I took Adam Roop's WebAssembly example, took his object.d, and kind of added the things that I needed for this project to actually work. And yeah, passed that to the compiler. So this was my build command, like it specifies WebAssembly stuff. But also, it lists this on the command line. If you just put it in the root of your directory, it will always use it, which isn't ideal. But this way, when you pass it, D will use your own runtime instead of the installed one. Another quick demo. Let's see. So this was a small web application that I made. And it's very interactive. You can just type formulas, and it just prints the result as you type it. And you can make your formulas very complex. Also, it has a lot of features, like even octoliterals. I can answer Walter's question very easily. It also has binary literals, because I like them. Yeah, so it's almost actually a programming language. I thought if I just add variable assignment and a few statements, it's probably Turing complete, but I refrained. I haven't programmed my own programming language yet. It leaks memory because I haven't implemented actual GC. It just uses the null GC, meaning allocate, never free. And yeah, Sebastian knows more about why it's difficult to implement GC in WebAssembly. So that's an ongoing challenge. But for now, it worked OK. I haven't used it for so long that I got any problems yet. And I could also just occasionally restart it if I really need to. As for the drop-in float, I got very far, but there are a few instances where the D language is not powerful enough to have a truly custom number type, like implicit conversions or construction. If you have an array with number literals, you cannot make it implicitly convert to your custom number type. You have to add like a constructor call for that. But if you take that into account, it is still pretty easy to just write code that works with either a basic number type or your own custom number type, which is really nice. So my final example is running Dcode on the graphics card, except I didn't actually run Dcode on the graphics card. But I think it's an interesting case study because it kind of shows what happens when you are using two languages and one of them is D. So the difficulty is that usually what we've done so far is we fed our source code to a decompiler, and it generates code for a specific target, like x86, your usual, what most desktops use, WebAssembly for the browser, MIPS for my Nintendo 64 emulator. But graphics cards don't have easily defined instruction set like that. Usually what you have is an API, like DirectX, OpenGL, or Vulkan, that translate your shader code in some shader language to something the GPU understands. And it varies per GPU vendor, from NVIDIA to AMD, and also older and newer versions. They change a bit. And there are some, there is progress in having something like SPIR-V, which is kind of like WebAssembly as far as I understand it, that it's like an intermediate thing that compilers can generate, and then it's easily translated to actual GPU instructions. But so far, I stuck to OpenGL. That's what I'm familiar with. So here's how OpenGL works together with D. So let's say we're rendering a simple triangle mesh. We usually make models from triangles. The corners of these triangles are vertices, and they are an important piece of data that's needed to render these models. So you have defined this structure that, in this example, has two attributes for each vertex, a position in 3D space and a color. And then you have your shader code. This is not D, but GLSL. and it takes some vertices with attributes. And in this case, it multiplies a matrix, which allows you to have some transformations like rotations and scaling, and that gives it its 3D look. And of course, this is just a very simple example. Actual graphics have a lot of more components than just the rotation. But how does GLSL know? Like, it expects these attributes. How does it know our actual struct layout that we use in D and that we send and that the data has that we send to it? That's what you do with function calls. So you have to define a vertex attribute array which describes all the attributes. And you have to kind of tell, like, oh yeah, this position is float. It has 3 elements. It has stride of 16, like, because the struct size is 16 and offset. And this is, of course, very brittle, because if you change any of this, you also have to change that, or else it just is a mismatch, and you don't have any type safety at all. I think that OpenGL has like the worst type safety I ever experienced, and I've made handwritten MIPS assembly. Because when you look up in graphics, you get a black screen, and you don't know what am I supposed to do with this. Like, I can't step through it. I just have to guess what went wrong. Well, occasionally you get lucky and you inadvertently create some abstract art. And from the artifact, then maybe you can backtrack and kind of figure out what went wrong. So let's improve this using D. First step is to avoid the magic numbers and try to document nicely what we're actually passing. So components, we access the length of this static array, and we use size of and offset of, which alleviates some of the magic numbers, but we can do better with D, of course. We can actually just generate all the right calls in one go. So what this little piece of code does is it defines a function, takes a generic vertex struct, so we can pass this to it. Then it iterates over all its fields using tuple of. It queries the array type, it queries the element type, and then based on this inspection, it automatically passes the right constants to the function call. And this is very robust. I can just change my layout however I want, and it just still works. And this is a minimized example, of course. But in my real code, I expanded this to support basically all the other OpenGL types. Like, you don't just have float vectors, but also integer vectors. And there's also something I still want to do is support not just an array of structs, but a struct of arrays. And that can be more efficient for cache in certain circumstances. But I've been very happy with the results so far. What I've also done is automatically generate the GLSL code, because like, why do I have to write this if I know, like, if I can give a vertex struct, I can also generate this part of the shader, and I don't have to write that myself. So using D with metaprogramming, it makes interfacing with other languages very ergonomic, but I still prefer to just use D everywhere. It's still not perfect. There is still some friction that I don't know how to get around. An example is in a D struct, Booleans are 1 byte. In GLSL, they are 4 bytes. Another difference is the array syntax is reversed. It uses like the C convention. And also, this is a dynamic array, which is under the hood a pointer and a length. But GPUs don't like pointers at all. What actually happens here is it puts the array in the struct, which is also why it can only appear once at the end of the buffer, because you don't know how large it is, and if you put something after it, you don't know where to put it. And so there's still some mental friction where I have to kind of switch with, oh, right, this is not a D type, this is a GLSL type. Hence, I wish to switch maybe sometime to also write D code in shaders. Wrapping up. So the point of this talk is not that D is a paragon and all the other languages are just tats. There's a lot of merit in other programming languages. They're doing really nice things, and I also have a lot of pleasant experiences with other programming languages. But like from my perspective and from my experiences, D was just a really great fit, even if it didn't like have all the support out of the box. I like tinkering with it and doing some things myself and see if I can use it even here, even inside a Nintendo 64 emulator or something. And yeah, the disadvantage is that D is a bit of a complex language. I wish it were a bit simpler. But the reward for it is that if you get things right, like slices and stuff, then you're able to write reusable, robust, and flexible code and run it everywhere, and I don't have to rewrite my algorithms for different languages. And that was my talk. Thank you.
All right, so question time. Who's got a question? Up there.
Right, so have you tried anything with automatic differentiation? Because if you haven't, you might like it if you've enjoyed implementing computer algebra.
Automatic what?
Automatic differentiation.
Differentiation?
Yeah.
I don't know what that is.
You'll like it.
OK, I'll keep it in mind.
And then one other thing is that have a go with DCompute, which for anyone who doesn't know is the D on GPU solution. It's not there yet for graphics shaders, but for compute shaders, it actually works much better than you'd expect.
Yes, I've been meaning to try that out. I was aware of it.
Shout out to Nicholas Wilson.
Yeah, there's another trick, which is you can use GL shader binary, and that will, in AMD GPUs, I think it just spits out an ELF binary, which then you can patch and reload. And that could be another trick to just, with an LVM backend, you could get AMD GPU code out and then patch the ELF file with whatever D code you want, and then reload it. The thing is, I'm not sure, like, you know, how those like inputs and outputs would work. I've never done that, but there was a pretty cool talk which I'm trying to remember the name of about that, which could be pretty interesting.
All right.
For your use case.
But are you talking about OpenGL using this? Because OpenGL has a way to save binary, but it's not a binary that's portable. It's just for the computer you run it on.
Yes, that's the only disadvantage.
But
for AMD GPUs, pretty much it's always the same, and you would only need to have a small switch depending on the vendor, but it would be mostly portable-ish.
Yeah,
All right.
I do not recommend that.
No, it's fine.
Any more questions? No, what's that? I made a joke in the chat that I was going to suggest that you put DConf into Mario. And now I'm being reminded that I made a joke into chat. So any chance of a DConf in Mario demo?
Let's see. Here we go.
Yeah, I don't think I'll ask you to replace Mario's voice with DConf, but
Let's repeat it a bunch of times. Let's see. Let's go.
thank you, Mario. All right, surely somebody there must be nerds in here that like Mario. Any Mario questions? Come on. Nah, I think this looks like a crowd that wants to have a break. All right, well, thank you, Dennis.